In this video, we're going to be looking at Newton's method, an application of calculus in order to find zeros of a function. So let's go ahead and let's look at the objective. Okay, so what is it that we're trying to do? We're trying to find an approximation of a zero of a function using Newton's method. Okay, and of course state the formula for Newton's method. Now, when I look at the first objective, I hope you understand what I mean by the zeros of the function. Let's pretend I have a function here, and this function has actually two zeros. My first zero is going to be a negative value, and my other zero is going to be a positive value. So the zeros are where the function crosses the x-axis, or you can honestly say that they're called the x-intercepts, or where the y values are 0. Okay, so we're going to be looking at Newton's method. Now, what are the prerequisites that you need in order to be able to do Newton's method? You have to know what a zero of the function is, which I clearly defined prior to this. Know that all zeros of a function have a y-coordinate of 0, which I have already stated. You got to be able to take derivatives. And finally, you need the tangent line formula, and the tangent line formula comes from the slope formula. Remember the slope formula? M is going to equal to y minus y sub 1 over x minus x sub 1. So then if I take this quantity and I cross multiply it, I'm going to end up with my slope, which is this guy, times x minus x sub 1, and then y minus y sub 1. That is very important. Now, what is Newton's method? If you're given a function f, we want to be able to find the zero of f located at x. So we're trying to find where that function crosses the x-axis. So what we're going to need is we're going to need a starting point. Okay, this is going to be a starting point, and I'm going to call it my first guess, x sub 1. All right, and the slope at x sub 1 is going to be defined as f prime of x sub 1. And what Newton's method is going to do is it's going to take, let me go ahead and draw a graph here, and what I'm going to do is I'm going to draw a tangent line, and this tangent line is going to give me that x-intercept, but this is the one I want. So now what I'm going to do is I'm going to do another tangent line now. So I'm going to find the tangent line now at this dot, draw the tangent line, and it's going to give me that dot, and then I draw another tangent line. And every time that I draw a tangent line, we're going to call it an iteration. The more iterations, the closer your x-intercept of your tangent line is going to be the zero of the function. Okay? So, here we go. So, I am giving x sub 1. This is going to be called my guess. And I'm going to have my slope at my guess, which is very important. This is my slope, which is going to be defined right here. And remember, we're given the x sub 1, so now I need my y-coordinate. And the y-coordinate, you take the x sub 1 and you plug it into the function. So you're going to get f of x sub 1. So this is the tangent line at my guess. Okay? So we want to know the zero of the tangent line. So I want to take this guy and I want to find the zero of this guy. I want to find the zero of this function. Now, what does a zero of the function mean? Okay, so let me go ahead and restate it. It was one of the prerequisites. Here's my zero, and that guy has some x comma 0. And what do I notice about this? That this guy, he's going to be 0. So that means that y is going to be 0. Okay, so that's very, very important before I proceed. So I want to find the zero of my tangent line. Okay, so I'm going to insert the 0 into my y-coordinate, because remember, I want that 0 of the function. Now I'm going to have negative f of x sub 1. Negative f of x sub 1 is going to equal to f prime of x sub 1, x minus x sub 1. Now remember, x sub 1 is my guess. That's what I originally wanted. So this is the guess, this is a slope at my guess, and this is the y-coordinate of my guess. So what I'm going to do is I'm going to take this guy now and I'm going to move it over to the other side. So now I'm going to end up with negative f of x of 1 over f prime of x of 1. And that's going to give me x minus x of 1. And now I'm trying to put all the ones I have my guess into one side. So this guy, I'm going to move this guy over to the other side. So that means that x is going to equal to x of 1 minus f of x of 1 over f prime of x of 1. And this is going to be the 0 of my tangent line. So this 0 here, he's the x coordinate. It's going to be the x coordinate of my 0 of my tangent line. So he's going to be now my new guess. It's going to be my new guess. And what do I do with this new guess? I plug it back into my Newton's method formula to get another guess. And then that's going to give me a tangent line, and I want the 0 of that tangent line to give me a guess, so I can find another tangent line. So you're saying, I have no idea what you're talking about, Mr. Quintana. Okay, here we go. Let's look at the visualization. I have this dot here, this dot right there, and I have my tangent line. The black line is my tangent line. And this black line is going to cross right there. So this is the 0 of my tangent line. Okay, and I'm sorry about my writing, okay? I'm getting used to writing with this right pad. So now this 0 here, that 0 that I have right here, he's going to be an approximation of this, but it's not close. That's only one iteration. So I want to do another iteration. So that means that this 0, I'm going to go up, and I'm going to put it right there. I'm going to draw a tangent line now there. That's what I want. I want a tangent line. And that tangent line is going to create another 0. And if I was to extend this red line, I don't know if you see this red line here. This red line is going to be extended, and it's going to cross right there, which is way closer to what? To my real 0. The more iterations that you do, the better that it's going to graph. Now, before I work it, I really want to work an example. I went to the internet and I found this amazing applet that I found, and it's going to show us. So I'm gonna go straight to the applet, and what I have here is I have a function, and what I'm going to do is I'm going to start I'm going to do this one here. Okay, so if you notice, right here is going to start off with my guess. What is my guess? What do I want my guess to be? If I want my guess to be, let's say I want my guess to be 8. Okay, now remember, I'm trying to find this 0 here. And what it's doing is doing an iteration here. So my first guess was 3.9. Then I found my next 0 of my tangent line was 3.61. Then I did it again, 3.47. And what do you notice about the fourth iteration? They start to almost repeat. Only the very end here is changing. So what it's doing is, let me try to find this 0 over here. Okay. So the further your guess is, the more iterations that it would take to get to the real 0. So let's pretend like right here we know that my 0 is 3. So I'm going to move my cursor over to 2.4. Okay, so if you notice, my third iteration, my fourth iteration, my fifth iteration, oops, on my sixth iteration. So let me make it, let's go with 2.9. If I had tested 2.9, I'm going to almost get there on my fifth iteration. Okay, now what happens if I go further out here? Let's pretend I go further and I went with this. Oops, that one's going to find me. Did you notice something here? That if my guess is way off, my tangent is going to cross me over here and it's going to find me the other 0. So got to be careful. Okay, so right here I'm going to go with 8. See what 8 gives me. I'm trying to find my 0, and my 0 is going to be located at, and that's 9 iterations, that's 10 iterations, 11, 3.4074. So that's going to be 10 iterations. That was a horrible guess. So when you try a guess, you want to get something that's close. So for me, what I want you to do is I want you to find me my 0, but I'm going to be giving you a function. I'm going to give you what? Now this function has two zeros, okay? If I plug in, oops, this is supposed to be 2 and -2 here, right? And what I want to do is I want to find one of the zeros, okay? So we're going to use the Newton's method. Now, what's the formula for Newton's method? Newton's method is going to be x of the new guess. This is, I'm going to call this guy the new guess here. Is going to be the guess minus f of the guess over f prime of the guess. Okay. So what I'm going to do is I'm going to pick 3 as my guess. All right. So my guess is going to be 3. So I'm going to go 3 minus f of 3 over f prime of 3. Okay. So I need, my function is given to me. So what's f prime? F prime of x is going to be 2x. So that's going to give me 3 minus, well, 2 times 3 is 6. Oops, that's in the wrong spot. F of 3, I'm going to take my 3 and I'm going to plug it in my original function. So 3 squared is 9, 9 minus 4 is 5. So it's going to be 5 over, and when I plug in my derivative, 2 times 3 is 6. So that's going to give me 3 minus 5, 6 is going to be 2 and 1/6, which is going to be 13 over 6. So guess what this is? This is my new guess. So now remember, I know that the 0 is 2, and that guy is not 2. That's going to be 2.2 and 1/6. So let's do it again. So I'm going to take 13 over 6 minus f of 13 over 6 over f prime of 13 over 6. And we're gonna need a calculator for this. So I'm going to take out my CAS here. So I'm going to take it out and let me go to home screen here. Let me go to a new page. Okay. And we have 13 divided by 6 plus or minus, and we're going to do open parenthesis here, 13 divided by 6, and I'm going to square that. Oops, I forgot to put see, control divide. There you go. So then on top here I can say it's going to be my function. So let me go back to my function. It's x squared minus 4. It's this squared minus 4 over the derivative, which is 2 times 13 over 6. Okay, I press enter, and that's not giving me a very good. Guess what I'm getting now? I'm getting 2.00641. Remember, the real 0 is 2. So that's after 2 iterations, I'm already there practically. Okay. So what am I trying to do? I am trying to find this. What we said was what? 2.00, and let me see, let me recall it. It's 2.00641. 641. Okay, so this was 2 iterations. So what am I going to ask you to do? I'm going to give you a function as is, and I'm going to say find me my 0 of my function, but I'm going to tell you the starting point, and I'm going to tell you how many iterations to do. So please know the formula. What's my formula? So it's going to be x, and I like to put new guess here. My new guess is going to equal to x of the guess minus f of x guess over f prime of x guess. So when I work this guy out, it's going to give me my new guess. And so then once I have this, I plug it back into the formula, and it gives me another new guess.